Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. Hi there, and welcome to Outcome 6, the last outcome video in the 2396 series, going through the requirements of the course. We're going to just look at the last little bit that is required in the assessments, and then we're going to introduce some mock assessments that I have created for further study on this. And what I'll do following this video is we'll have a couple, probably a handful of videos going through the design process stage by stage, working on the mock project that is included at the end of this video. Alright, so to start with, outcome 6, it's from the assignment area, so it challenges the assignment area, and it's just to be able to apply design and verification procedures for single and polyphase electrical installations. There are, with the project, 6 questions as well, and I've got some examples of these included, just to kind of pick your brains at your design work. So you'll need to apply the design calculations relevant to the installation's design, select suitable installation components, provide information, obviously handing over to a client, and then actually critically compare the criteria that is designed to the criteria that is either returned to yourself as a designer or as the constructor from the initial verification, to make sure that it is as designed, so to speak. So individually with these, yeah, you need to have a good understanding on the way to use the formulas. You'll have access, obviously, through the project to have all the resources at your disposal, but do be familiar with the important ones. From the wiring regulations course that you've probably or hopefully have done before, you would have gone through hopefully a selection in a part 5 area on the cable calculation process using a lot of appendix 4, where you did IB, IN, IZ, IT, CA, CI, CG, all of that stuff. I did do previously in this series a little example cable calculation video. Revise those formula and just be familiar with them. You'll have to understand how to use the adiabatics, both of them, verification of volt drop, and also some of the formula required for testing. That's probably as much as you'll need. You may, obviously, depending on the circumstance, you may need to be able to dabble with a bit of power factor, such as just using the power factor with your design current calculation. You probably won't be challenged on anything from a trigonometry perspective, such as verifying values of impedance or reactance, because that's more of a component or a particular circuit designed for a specific load. They won't go into that level. They'll try and keep it simple so that you're just going to apply these formulas here. The next bit, select suitable electrical installation components. So obviously your scenario, your design should be descriptive enough to give you a good understanding on the environment, so the users, the utilization of the system, the building structure. And with this information you can then decide on consumer control equipment, what is suitable, types of equipment. Is it simple plastic switches? Is it needs of industrial? Is it needs of isolation, mechanical maintenance, switching, functional switching? What methods of switching control are needed? Earthing arrangements. The design will actually, in the scenario, give you the supply characteristic earthing arrangement. With that, you'll then obviously move forward with the design. And the external influences, again, that's down to the individual scenario that is described. So it might be commercial, it might be industrial, it might be it might be domestic, but further on it could be horticultural, it could be agricultural, it could be a hospital, it could be a swimming pool. So have a good a general viewpoint on those and understand how they would vary with the different external influences. Wiring and containment systems, same thing as above really. Cables and conductors, decide your cable types. With your design, you're obviously going to state what type of cable. You're going to state the thermal limits of the cable. You're going to state the volt drop of the cable and the even the manufacturer. As I said in the previous videos, if you can actually maybe go to the manufacturer and capture a data sheet and add that. That will then support your decision-making process. That would be great. Conduct a cross-sectional area. We'll have to prove our selection of cable sizes with accurate calculations. Protected device types. Yep, we'll have to decide why we're going to choose a BS3036 fuse over a BSTN 60898. Probably not going to do that, are we? So we're going to make sure that we achieve suitable protected devices. But first of all, we may need to determine what we need with regards to additional protection for safety, what protective measures are in the installation. That might dictate what type of protective devices we select anyway. Similar with earth fault protection, is it needed, is it not needed? If you have part of your installation that is electrically separated, for example, so there may be certain circumstances for part of the installation. But once you know the scenario, you can kind of take all of that a little bit at a time. Same with earthing and bonding, isolation switching, accessories. It all depends on the circumstance given in the scenario. But do be aware of the content of BS7671, what it actually says with regards to selecting different types. You'll probably find in your bigger exam, the sat-down ready exam, that's what they're looking to achieve in that exam. So you'll have one question which will say, here's a scenario, we're on a construction site, and then it'll have a couple of questions chipping away at that. And some of them will be from the main content of BS7671, but a good chunk of those will be from 704, which will be obviously with regards to external influences, RCD protection, cable selection, and things like that. So familiarity with the regulations is essential here. Transformer types, final circuits, distribution circuits. Obviously, if we're going to have a distribution circuit, we need to make sure we consider volt drop, make sure the volt drop isn't the maximum value of volt drop, because we have to have an allowance for further distribution or final circuitry. Also, the disconnection times change according to a distribution circuit or a final circuit. So, you need to establish the differences between the two. We'll also notice with the design criteria, we need to look at the maximum demand and apply diversity. So, establishing the difference between your distribution circuits and your final circuits is very important for that point as well. And lastly, SPDs, if relevant. 6.3. Provide information relating to the electrical installation design in a suitable format. So this is all about your handover, really. How you're going to hand over the information to the client. So, what drawings will you provide? Will you draw them, complete them? There is an operation and maintenance manual. There's mention of that in Guidance Note 3. There's mention of that in the IET's maintenance manual. It'll compile the installation certificate. It'll compile the manufacturer's criteria. But also, maybe depending on the scale of the installation, actually give instructions to the users on the operation of the system and isolation of the system. There's some very good sample OEMs. You won't have to necessarily create a full drastic OEM. What you'll probably need to do is just compile your drawing in the project and provide as much information as you can that supports the design, and then provide what would be a duplicate of the anticipated initial verification values, really, or some kind of documentation that says these are the anticipated initial verification readings. You don't really need to kind of create a drastic OEM manual that goes, this and this and this for a procedural perspective. It's more a case of compiling the information, but making sure the information is legible, and making sure the client, the recipient of the information, can actually use it. All of it is very relative. When we do our design, we're going to obviously obtain values of anticipated or calculated full loop impedance, ZS. We'll also verify things like prospective fault currents with our supply characteristic information, R1, R2s with our installed cable circuitry, etc. However, there's a difference between what we expect in design and what we have in reality, and we need to understand where those expectations can differ. So if I had an insulated system, such as a twin and earth system, like a domestic installation or a small shop or something, and it was an insulated sheath system, surface clip direct, I won't expect parallel paths to make much of an impact on my ZS values, and I expect my R1, R2s to be pretty much as calculated by design or determined by design. But if I was installing such as in a factory with still trunking, still conduit kind of systems, and we're going to go to the back boxes with each one. R1, R2s can be verified before the parallels are introduced, but really the initial verification will include them after installation with all the other circuitry, and so there will be an anticipation of parallels. So we'd say, well, what does that mean from our review point? So we'd say, okay, well, those R1, R2s that we obtain via measurement will probably be a little bit less than the value we've got by design. So those ZS's will also be a little bit less than we have by design. The prospective fault currents may be a little bit higher because of the reduced circuit impedance that we have compared with the design. If, however, we have a value that is measured that is exceeded, we have to understand what kind of problems could create that. So it could be high resistive connections within our selected switching devices. It could just be simple poor installation or erection method. But we have to be able to look at the design criteria, look at the criteria provided by initial verification, look at them and determine to what degree we're satisfied with that. That's that whole outcome done. What I'm going to add, I'm going to put a link in the description to this video, will be a link to a Dropbox download. The Spark Ninja website will be launched very, very soon. This is going out still in May, but the Spark Ninja website will be launched in June, and we'll have all the downloads and documents on that. But for now, I'm going to use a Dropbox link. I'll update the link with the video description if it changes later on. But if you actually do download that and you choose to have a go, you'll have these documents in there. There's a mock assessment, which is obviously going to be an open book assessment, which challenges your ability to use the regulations and understand design. It's fairly simple, I'll be honest. Okay. The other two documents combined for the project, so you have the scenario of the project given, so it gives you the utilization of the building, the walls, fabrics, the supply characteristics. It gives you who's responsible for this, who's responsible for that, and then there's a drawing to go alongside it that you can then use to lay out your circuits and things. If you want to have a go at them, then have a go at them. They're downloadable via the link in the description. But I'm going to then start creating some videos to go through these. I'll probably start with videos that go through the mock assessment. Might actually do that in one video. It might be a little bit long, but I'll go through that in one maybe. And then I'll start doing some on the design. Now the design will be quite large. I mean, typically you're looking at 40 plus hours to work on this. I'm going to simplify that the best I can and just go. I'm going to explain some procedures for 2 or 3 circuits, and then I'll just say I'm going to apply that for the rest, and then we'll see what we get at the end. I'm not going to go through the whole process on a video. I think that'll be too lengthy. But let's move on with that, and we will see. I'm probably going to take a week or so for me to upload this next video. But that's the rest of the course kind of presented to you. If you want to have a go at this, then links in the description. Have a little play. You can email me. If you look at my about, you can get an email address if you want to email me a bit of feedback on a question, interpret a question, or submit, and I'll have a look. If you want, it's up to you. Alright guys, good stuff. Enjoy the rest of your bank holiday weekend if you're watching this right now. And I will see you probably in a week. Yeah. Cheers, bye.